Subject: Design and Analysis of Algorithm, Module 3, Greedy Technique. Today's topic is Kruskal's algorithm. Kruskal algorithm is used to find the minimum spanning tree for a connected weighted graph. How many edges does a minimum spanning tree has? A minimum spanning tree has v minus 1 edges, where v is the number of vertices in the given graph. If the graph consists of 5 vertices, then the total number of edges in the spanning tree is 4. Below are the steps for finding minimum spanning tree using Kruskal's algorithm. Step 1. Sort all the edges in ascending order of their weight. Step 2. Pick the smallest edge. Check if it forms a cycle within the spanning tree formed so far. If the cycle is not formed, include this edge, else discard it. Repeat step 2 until there are v minus 1 edges in the spanning tree. Problem: obtain minimum spanning tree by applying Kruskal's algorithm for the graph shown below. A given graph, it consists of 4 vertices A, B, C, D and 5 edges. To solve this problem, we have to consider two columns. First column is selected tree edge, and second column we are arranging the edges in ascending order. Step 2. Sort all the algorithm. Step 1 is sort all the edges in ascending order of their weight. Okay, here we have to sort the edges in ascending order. The sorted edges are BC1, BD2, DC4, AD5, AB5. Step 2. Pick the smallest edge. After picking the smallest edge, we have to check whether it forms a cycle or not. If it not forming a cycle, then only we have to consider that edge. If the selected edge forms a cycle, then we not have to consider that edge. Now the spanning tree, it consists of 4 vertices and 0 edges. First I am selecting the smallest edge BC. So observe the figure spanning tree. If I select the edge BC, it does not form any cycle. So I am selecting the edge BC. After selecting the first edge, and next in the second row, again you have to arrange the remaining edges in the order. Last step in the algorithm is repeat step 2 until there are v minus 1 edges in the spanning tree. In the given problem, v value is 4. So total number of edges in the spanning tree is 3. But right now there is only one edges in the spanning tree. So I'm going back to the step 2. Again in the step 2, pick the smallest edge. Okay, the smallest edge value is B2. If I pick the smallest edge B2, it does not form any cycle. So I am considering that edge. Next, arrange the remaining edges in order DC4, AD5, AB. Now the number of edges in the spanning tree is 2, that is not equal to v minus 1, that is 3. Go back to the step 2. Pick the smallest edge. Smallest edge is DC, that its value is 4. If I select the edge DC, see what happens up in the figure. It forms a cycle, so I am not selecting the edge DC. Next edge is AD. Its value is 5. If I select the edge AD, it does not form any cycle, so I am considering that edge. Now algorithm step 3. The total number of edges in the spanning tree is 3. It is equal to v minus 1. Number of edges in the spanning tree are 3, that is equal to v minus 1. Next I am calculating the minimum cost of the spanning tree, that is the counting the edge weight. 1 plus 2 plus 5 equal to 8 units. I hope everyone you understand the how to apply Kruskal algorithm to find minimum spanning tree. Okay, if you does not understand this one, repeat the video and understand it. Practice question 1. Apply Kruskal algorithm to find the minimum cost spanning tree for the given graph. Students, solve this one and submit your answer in Google Classroom. Practice question 2. Apply Kruskal's algorithm to find the minimum cost spanning tree for the given graph. Okay, students, solve this problem and submit your answer in Google Classroom. Thank you.